This lesson is our introduction to Unit 1, and Unit 1 is titled The Nature of Chemistry. So we're in, just started the new school year, and we're in this course called Chemistry. So, what exactly is chemistry all about? What's the nature of chemistry? So, on my opening slide here, you'll notice that I have pulled in some pictures and just want to kind of touch on some real life applications of each of these and how they do tie into chemistry. Chemistry does affect our everyday life. Here you see a picture of a young girl with a backpack, a nylon backpack on her back. Well, if it weren't for a chemist, she would not have the material used to make that backpack. Nylon is created in a laboratory. So here's actually a beaker with the person's holding a stirring rod, and that's just some nylon string that's been created here. So that is a man-made fabric, very strong and durable. In this picture, we see a very magnified version of what Velcro would look like. So the Velcro, this green part here, like the hook, that's the rougher part of the Velcro, and then these little tiny yellow strands here are the softer part of the Velcro. But Velcro, of course, um, whenever you connect the hook and latch system here is uh, holds pretty securely. Over here, you see a mortar and pestle where you can use to grind different herbs and spices, but also pharmacists would use those in a pharmacy if they were a compounding pharmacist. And then down here at the bottom, you see all these beautiful colors of the leaves. This is a result of a chemical reaction that takes place in the leaves as the weather changes. So chemistry does affect our everyday lives. So what is chemistry? Chemistry is defined as the study of all substances and the changes they undergo. So you're studying all substances, and we're going to learn in this first unit how does a chemist define a substance, and then the changes that those substances undergo. So substances could be like compounds, like water is a substance. Um, you could study water and you could freeze it. You could heat it and it would boil. Those are changes that substance would undergo. Physical, chemical changes. You could decompose water. I know that sounds kind of weird, but you could decompose water. Um, Other types of substances could just be elements. Like you might just study carbon, okay, the element carbon. You could study its reactivity. You could study its hardness. You could study its um, conductivity, its melting point. Anyway, these are substances. Substances are elements or compounds. Chemistry is defined as the central science, meaning it's central to all the other sciences. You cannot name any other science that chemistry doesn't somehow play a role in. It is the central science. So there are 5 main branches of chemistry that you need to be familiar with. 5 branches of chemistry. The first branch of chemistry is called organic chemistry. Organic chemistry is defined as the study of all substances that contain the element carbon. So notice here in my slides, I have tried to connect the key word in the definition with the branch of chemistry. So organic chemists study substances that contain carbon. So for example, many of these are called hydrocarbons. So like C8H18. This is a organic molecule that we all are more familiar with by its common name, octane. And of course, octane is found in gasoline. So notice the formula C8H18, it contains carbon. So organic chemists study carbon-containing compounds. The second branch of chemistry is known as inorganic chemistry. So thinking a little bit about word meanings and word origins, the prefix here in means without or against. So inorganic chemists study substances that are without or that do not contain carbon. So organic chemists study substances that do contain carbon, while inorganic chemists study substances that do not contain carbon. Next, we have physical chemistry. Physical chemistry is defined as the branch of chemistry that concerns theories and experiments that describe the behavior of matter or of substances, how they behave. Now, we don't normally think of molecules as behaving or water as behaving a certain way, but it does. Like water droplets on your car, they can bead together. They have cohesive forces. They have adhesive forces when they adhere to any other object, like, say, the hood of your car. The study of substances and their behavior is physical chemistry. Now, specifically, the behaviors that a physical chemist would study is the rate of the reaction, like how fast or how slow did it happen. That's called the kinetics. The mechanism, that's the step-by-step process by which the reaction took place. That also is tied in with kinetics. And then energy transfer. Does it release energy? Does it absorb energy? Does the energy not exchange at all? But a physical chemist would study the rate, the mechanism, and the energy transfer, looking at the behavior of molecules. Now, one thing that is not as obvious to most people about physical chemistry is this branch of chemistry is the one that requires the highest level of math background. Physical chemists require very high level advanced calculus. So physical chemists would require the highest level of math learning. Next, the fourth branch of chemistry is analytical chemistry. And notice the root word here is analyze. So analytical chemists are studying the composition, they're analyzing it, the composition of substances, quantitatively and qualitatively. So you would determine the makeup quantitatively, like what percent of carbon or what percent hydrogen is in the molecule, what percent of oxygen is present. But also qualitatively, you would analyze it qualitatively, and that would have to do like with color or texture or state of matter, a quality, like an adjective. You do need to understand the difference in quantitative and qualitative. So let's look at the root word here. A lot of science is all about vocabulary. So quantitatively, you see here the root word quantity. So quantitative information is describing numbers. Qualitative is more adjectives. Then we have biochemistry. Biochemistry studies the chemistry of living organisms, their processes, and their substances. So we all know that bio means life. So if something is living, it's alive. So the biochemistry is studying the chemical reactions that take place in living things. So let's just take a look here at this picture and let's just talk a little bit and review about these branches of chemistry. This is a slide from one of your pages in your textbook. And so At first glance, you see a picture of a young girl that's playing soccer. Well, we can relate all 5 branches of chemistry to this young lady. So, a chemist will study structures and processes in the human body. So, here you see this picture um, is talking about her lungs. A physical chemist would study the factors that affect her breathing rate during exercise. Now, we all know that as you exercise, you're going to breathe deeper and faster. So, what would affect the rate of your breathing? Well, a physical chemist would determine that, or they could study that. Remember, physical chemistry studies the mechanism, the rate, and the energy transfer of chemical reactions. Organic chemist. If it wasn't for organic chemist, she wouldn't have her nebulizer here, her medicine that she would take because she's asthmatic. So the organic chemist would be responsible for developing these chemicals that would control the symptoms of asthma. Most medicines that we take are or developed by organic chemists. Analytical chemistry. Analyze, you break it down. So here you see a picture of someone in a lab technician taking a sample of blood from her arm. So if, let's say, if she was tired and maybe they needed to try to figure out why is she tired, they might take a blood sample and they could maybe examine the amount of iron in the blood, or if there's any um, medicines in her blood that maybe she wouldn't maybe wouldn't be aware of. Down here we have biochemistry. A biochemist might study how the energy is used for the contraction of the muscles that is produced and stored. Okay, this energy. And then finally, an inorganic chemist would be explaining maybe how a lack of calcium in her diet could affect the growth and repair of the bones. Your bones, obviously, to have strong bones, we need calcium in our diet, and calcium is not carbon. We do, from our diet, we get a certain amount of calcium. So that sort of sums up our branches of chemistry.